In problem number 1, we're going to graph an exponential function. First, I look at my base. My base is 4.2, so this is an exponential growth, so I know that's what my basic graph is going to look like. I am going to pick easy points to graph this. So first I pick -1. So I plug in -1, and that makes the 4.2, which is the base, the reciprocal. So that's how I got 1.4. So here's my first ordered pair. So I plot that on the graph. My next point, I always pick 0. Anything to the 0 power is 1. That's how I got 6. So I have the ordered pair 0, 6, and plot it on the graph. My last point I pick is 1. So I go ahead and plug that in. That's how I got 25.2. So here's my point, and I go ahead and connect them, and it looks just like an exponential growth that I expected. But make sure you look at your coefficient, so that's going to make it more narrow. If that was my coefficient wasn't 6, but it was a fraction, it would make it wider. And then if I had plus or minus after my exponential, then that's what would move it up or down. In problem number 2, I'm going to use this equation to figure out the exponential growth of a population of birds. So I look for my initial amount. That would be 565. And in the problem it says my rate, my annual rate of 14%. So here's 14%. And the number of years is 3 years. So I'm going to plug this into my calculator just like I wrote it. And I have to round this up to the nearest bird. That's how I got 837. In problem number 3, I'm going to write my exponential function as a log function. My base is 6. So here's my base. So I have log base. My power is 5. So here's my power. My value is 7776. So I am going to check this. And the way I check it, I go 6 to the 5th power should equal 7776, and it does. So in problem number 4, I'm going to convert to a log. So my base is 7, so I have a base of 7. My value is 49, so I have 49. My power is 2, so I have 2. So now I'm going to check it to make sure it makes sense. 7 squared is 49. Correct. I'm going to take a log function and write an exponential function. So I have log base 4, so my base is 4. My power is -2. If it's a negative, I need a fraction for an answer, 1/16, and that is correct. And number 6, my base is a plus b. So I have my base a plus b to the power of 16. That's how I got 16 equals C. In problem number 7, I'm going to evaluate the log. So 4 to the x power equals 64. So I am going to factor 64, and I factor 64, but I only factor it down to 4 times 4 times 4. That way I have the same base. You can factor it down to 2's if you want. You will still get the same answer. So now I have the same base, and all I have to do is read. So I have x to the 3rd power. On number 8, I have 6 to the x power equals the value of 36. So I have 36. So I factor 36, gives me 6 and 6, which happens to be the first base. So I have 6 squared, and I notice x squared. When I plug that in to see if it's correct, it is correct. In problem number 9, I'm going to write as a single log. First thing I'm going to do, I am going to take my coefficients and move them back as exponents. So here they are as exponents. This operation says plus. So remember, I used log to solve in the exponents. So I have the same bases and I multiply them, I'm adding the exponents. That's why I take y cubed and t to the 6th power. That's why I'm multiplying those together as one common log base b. In problem number 10, I am subtracting. So if I was subtracting and I had the same bases, that means I would divide. So I have log base 3, I have 100 divided by 10. That's how I got log base 3 of 10. Problem number 11, I have log base 11 for both of them. I am subtracting. That means if I was dealing with the exponents, I would be dividing. So 16 divided by 2 is 8. So I got log base 11 of 8. In problem number 12, I'm going to expand my logarithms. So I have log base 6 of m divided by 2. That means I would be subtracting the exponents. On problem 13, I'm going to expand this. So 11 and a cubed are multiplied together. So that means I would add the exponents. And then I am going to take my power and bring it out front. That's how I got log base 3 of 11 plus 3 log base 3 of a. In problem number 14, we're going to use the change of base formula to evaluate the log base 4 of 26, because the regular scientific calculator only does base 10. So my log base 4 becomes my common log of 4, which is base 10, so that goes in the denominator. My common log of 26 goes in the numerator. So I'll go ahead and plug that into my calculator. That's how I got A for the answer. So in problem 15, I'm going to evaluate by changing the base. So I have to use my calculator. So common log of 8 goes in the denominator. The common log of 84 goes in the numerator. That's how I got D for my answer. In problem 16, I'm going to solve the exponential equation. So I notice right away 8 and 16 can be factored. So I factor 8, so that's how I got 2 to the 3rd power. Then I factor 16, that's how I got 2 to the 4th power. And I'm going to go ahead and multiply 3 and 6x, that's how I got 18x. And then I have 4, because I have the same base, so I'm going to go right to the variable. So I went ahead and divided by 18, that's how I got 2/9. In problem 17, I'm going to solve this equation, and I notice right away 11 and 29 cannot be made into the same base. So I'm going to take the common log of both sides. So I take the common log of both sides. That way I could take 8x and bring it out to the front, because that's one of my log properties. I can do that. So then I'm going to take both sides and divide it by common log of 11. So I have log of 29 divided by the common log of 11. That's how I got 1.40427. So I want to get x by itself, so I divide it by 8. It's at the nearest 10,000, so 4 numbers after a decimal. So then after I get that answer, I'm going to plug it back in to make sure it's correct, and it is. In problem 16, I'm going to solve 16 to 3x equals 116. I cannot make those into the same base, so I'm going to take the common log on both sides. So I could use my log property and bring 3x out of the exponent. So now I have 3x. I want to get x by itself, so I am going to divide both sides by the common log of 16. So I divide by the common log of 16, and that's how I got this number. And I have 3x. So I divide both sides by 3x, so I get x equals approximately 0.5715. I take my number, plug it in using my calculator to make sure it's correct, and it is. In problem number 19, I'm going to solve the log equation. It is a common log. That means my base is 10. I have log on one side of the equation, so I'm going to solve this as an exponential function instead. So 10 to the first power, that's where that came from, equals 8x plus 13. I want to get x by itself, so I subtract 13 from both sides. So now I have 8x equals negative 3, so I divided by 8. So that's how I got negative 3/8. I'm going to plug that into my calculator to see if it's correct, and it is. In problem number 20, I have a log on one side of this equation. So I'm going to change this as an exponential function instead. So I have 10 to the third power. So 10 to the third power equals 4x plus 5. I want to get x by itself, so I'm going to minus 5 from both sides. So 10 to the third power is 1,000. 1,000 minus 5 is 995. So then I'm going to divide by 4. And that's how I got this answer. And then I'm going to plug that into my calculator, into the original problem, and it is correct. In problem 21, we're going to write a single expression, but this time we have a natural log. A natural log is just log base e power. Because it's used so often, it's called natural log. So first thing I'm going to do, I'm going to take my coefficients and put them back as exponents. If I am adding, that really means I'm going to be multiplying. So 6 squared is 36. And then I have 6c, so I'm going to go ahead and multiply those together. Now I have one natural log. In problem 22, I'm going to solve a natural log equation. Remember, natural log is really base e, so I'm going to change this to an exponent, e to the first power. So I have e to the first power, and that's on my calculator. I put e to the first power. So I have 3x plus 4. I am going to minus 4 from both sides because I want to get x by itself, so I got 3x by itself. So I'm going to go ahead and divide both sides by 3, and this is what I get for an answer. And I'm going to plug it into my calculator to see if it's correct, and it is. In problem 23, I want to solve for x. First, I need to get x by itself, so I subtracted 4 from both sides. So I still don't have x by itself, so I'm going to divide by 7. And now I have e to the 2x. So to get rid of e, I'm going to take the natural log of both sides, because the natural log and e cancel each other out. So I end up with 2x equals the natural log of 2. Divide both sides by 2, so that's how I got that answer. In problem 24, I want to get x by itself, so first I'm going to divide by 8. So now I have my base e. To get rid of base e, I'm going to do natural log of both sides, and e and natural log cancel each other out. So now I want to get x by itself, so I'm going to go ahead and subtract 12 from both sides. And then I'm going to divide by 2. So I'm going to plug that into my calculator. I get this answer, and when you check it, you'll see it is correct. So in problem number 25, they give me a function to figure out the number of lawnmowers sold. They want the number of lawnmowers sold after 4 years. So I'm going to plug that into the equation and follow the orders of operations. So when I do that, when I get my answer, I have to round it up to the nearest lawnmower. That's how I got 20,289.